Hey everyone, and welcome. Get ready to go on an amazing journey of discovery, and you don't even have to leave your house. We're heading to the most unexpected laboratory of all, your kitchen. We're going to turn totally normal stuff into some seriously mind-blowing science.
I mean, seriously? Have you ever stopped to think about it? Hiding behind that pantry door, sitting inside your fridge, are some of the biggest secrets of physics and chemistry, and they're just waiting for us to find them.
For example, what if I told you you could whip up a material that just completely breaks the rules? You know, something that's a goopy liquid 1 second and a hard solid the next.
Or, get this, what if you could build a gorgeous, totally stable rainbow and trap it in a jar? Stacking liquids on top of each other like colorful floating bricks.
And for the big finish, a light powered by a piece of fruit? Yep, you heard that right. These are your missions for today. You ready? Let's do this.
Okay, let's dive right in. First up, the solid-liquid mystery. We're going to investigate a substance that just doesn't follow the rules, and we're going to figure out its secret together.
First off, just a super quick refresher. We all know the basics, right? Solids, like an ice cube, they hold their own shape. And liquids, like water, they flow, they splash, they take the shape of whatever you pour them into. Easy enough. But what about something that does both?
Time for mission number 1. Let's make some oobleck. This is so easy. All you need is some cornstarch and water. Just follow these steps, mix it all together, and trust me, you are about to create one of the strangest things you have ever touched.
So what in the world is going on here? Well, the one and only Sir Isaac Newton, he had some pretty solid ideas about how fluids should work. He figured they should all flow at a nice, predictable, constant rate. And you know what? Most of them do. We call them Newtonian fluids. But our oobleck, oh, it's a total rebel.
See, oobleck is what scientists call a non-Newtonian fluid. The secret is all about pressure, or really how fast you try to move it. If you slowly lower your hand into it, it feels just like a thick liquid. But if you punch it or squeeze it fast, it instantly turns hard as a rock.
And get this isn't just some cool party trick. This exact same principle is being used in the real world. Engineers have made pothole fillers that flow like a liquid to fill every single nook and cranny of a crack, but the second a car drives over it, bam, the pressure makes it turn solid. How smart is that? All right, one mission down. You crushed it. For our next experiment, we're trading that mysterious goo for a vibrant, beautiful liquid rainbow. And this one is all about a simple but powerful idea: density.
So, to build our tower, you gotta start with the heaviest thing first, right? The densest liquid goes on the bottom. And in most kitchens, that's gonna be honey. So, let's pour a nice layer of that right in the bottom of a jar.
Okay, next up, we're gonna carefully add our next liquids. We'll pour in some corn syrup. It's a little less dense, so it'll float right on the honey. Then, some maple syrup. And look at that. You can already see the layers forming, each one just floating perfectly on the one below it. To finish this masterpiece, we're going to gently add the rest of our layers, in order. We've got dish soap, then some colored water, then vegetable oil, and finally, the lightest of them all, rubbing alcohol. Remember, the real trick here is to pour everything really slowly down the side of the glass. You don't want to mix them up.
So what's the magic behind our rainbow jar? It all comes down to one thing: density. And it's actually pretty simple. If a liquid has more stuff packed into the same amount of space, it's heavier, more dense, so it sinks. And the liquids that are less packed, less dense, well, they float right on top.
And this is where it gets really cool. This little jar in your kitchen, it's showing you exactly how our planet's oceans work. I'm not kidding. As KiwiCo puts it, this mirrors how warm, less dense water in the oceans rises, while cooler, denser water sinks. And that process is absolutely critical for our ocean currents and regulating the entire planet's climate. All of that right there in a jar.
All right, you ready for the final mission? We're switching gears from physics to chemistry, and we're about to unlock a power source that's been hiding in plain sight. We are going to build a battery. And to do it, you only need 2 key items besides the lemon itself: a zinc nail, a galvanized one, works great, and a regular old copper penny. These 2 different metals, they're going to be our key players, our electrodes.
Okay, so here's the science. That sour lemon juice, it's an acid, and it kicks off a chemical reaction. Basically, it makes our zinc nail, that's the anode, get all loaded up with electrons that it's just dying to get rid of. And the copper penny, our cathode, is just sitting there ready to accept them all.
So you've got all these electrons on the zinc nail just waiting to make a move to the copper penny. They just need a path. And that's where a wire comes in. When you connect the two, you create a superhighway for those electrons to travel. And that flow of electrons, that, my friends, is electricity.
And the moment of truth, you connect a tiny little LED light into that circuit, and boom, it lights up. We have power. You literally just turned chemical energy into electrical energy with a lemon. And that unlocks the secret behind every battery in the world. From your phone to an electric car, they all use a chemical reaction to push electrons down a path, creating a current.
So there you have it. Let's just take a second to think about what we just did today. We've proven that your kitchen isn't just for making dinner. It's a full-blown laboratory for some amazing discoveries.
I mean, think about it. We saw how a liquid can act just like a solid. That's non-Newtonian fluids. We figured out how liquids can stack on top of each other, all because of density. And we literally powered a light bulb with a piece of fruit by building a battery. That's a pretty good day's work. You've turned your kitchen into a lab, and you've seen that there is extraordinary science in the most ordinary things. So the real takeaway here isn't just about oobleck or lemon batteries. It's that science isn't some far-off thing in a lab coat. It is everywhere. It's hiding in plain sight, just waiting for you to be curious. So, the only question is, what are you going to discover next?